Go to Canvas page, click on discussion, then click on 8.3.5 class activity. Click that activity. So in this pipeline, here the instructions are given to you. Just execute these instructions in 5-stage pipeline. Okay. Assume that there is no structural hazard, and in the data hazard solution, just follow the bypass and forward. Assume that there is an interstage buffer which can store the output of every stage in the pipeline. Okay, follow this bypass and forward solution. Okay, then after executing these instructions in the pipeline, please enter the total number of cycles. So below this, you're having this whiteboard. If you click on this, the full screen, okay, it will, the frame will be open to you. Okay. So here you start, click on the tables, click on the table here. Okay. And you follow the code. Okay. So what is given there? If I minimize this, so there are how many rows are required? 1, 2, 3, 4, 5 rows. And then the columns will be increased. You can add the columns as the execution starts. Okay. Is it fine? Right. Use this frame space for executing. Yeah. Just use the table, use the 5 rows, and let me use this column. Just type here. Okay. And here just type cycles. So give the number that cycle 1, cycle 2, cycle 3, cycle 4, cycle 5, cycle 6, cycle 7, and let's keep going on. So here the instruction, first instruction is what is the first instruction? Yeah, Haley, can you type the first instruction? If you minimize, or you can directly copy from here, but it won't work on copy paste. It is add R1, R2, R3, right? So you just type here, add R1, sorry, R1, R2, and R3. The second one is the subtraction. Let me use calculator. The second one is the subtraction of, yeah, the subtraction R4, R1, R3. So let me just quickly type it here. Okay. Subtraction R4, R1, and R3. Multiplication R5, R4, R3, perfect. And load, perfect. That's good. Yeah. So now You can start executing now. So at the first stage, the add instructions enters into, okay, let me just remove this frame then. Yeah. Let me extend this. Does that works now? Please. Yeah. Now you can use this. So in the first stage, in add instructions enters into the pipeline. So the columns is a pipe here, okay? In the second stage, add instructions enter into the instruction decode stage, and subtraction enters into the instruction fetching stage. So here you can observe that in instruction decode stage, the R2 and R3 values are reading from the register file, and subtraction instruction, okay, this, yeah. So the subtraction instruction is in the instruction fetching stage, means fetching from the instruction memory, correct? So at the third stage, add instructions enters into the execution stage, and subtraction instruction enters into the instruction decode stage, and multiplication instructions enters into the instruction fetching stage. So at the fourth cycle, instruction 1, that is add instructions, enters into memory access stage. So what about the subtraction instruction here? What about the subtraction instruction? That's wrong, because it requires R1, the source. R1 is required, but the R1 is, here, let me use this, that is not yet updated in instruction 1, that is add instruction, right? So then what to do in the pipeline? What to do in the pipeline? Yeah, but we have given that there is a, here let me use a sticker. We are having the bypass and forward. So there is a bypass and forward. So at the end of this stage, in the register interstage buffer, is this R2 plus R3 value is ready? R2 plus R3. So is this value can be used here further? This is ready, right? Is that right? So it should wait or it enters into the execution stage. So are you able to add it? Let me just open this. Are you able to edit this? Yeah. So then at fourth stage, what will be the entry here? Can anyone add it? Yeah. Asking correct. Wonderful. Yeah. Then the multiplication instruction move to perfect. And load instruction enters into oh really that's cycles. That row represents cycles. Perfect. Wonderful. Then at the fifth stage, at the fifth cycle, what happens? Yes, perfect. Correct, Haley. Wonderful. Yeah. So then what about the next instruction in the fifth stage? Perfect. Next instruction. Multiplication enters into which stage? Yeah, Jonas. Perfect. Good. So that adds R4 plus R3. Very good. Then the load instruction will enter into which stage? Yeah, really correct. Yes, instruction decode stage. Perfect. Right. So five stages completed. So at fifth stage, add instruction completed its execution. Good. And right, this is forwarded here. So this value is forwarded here. And this value also forwarded to. It won't require. Okay. That's perfect. So then just fill the entries in the sixth stage. Wonderful. Good, good. LA is doing yeah, memory access stage. Perfect. And then execution stage. Wonderful. Yeah. Then fill the seventh cycle. The pipe. Yeah. Jonas, correct. Memory, perfect. So then let's add the another column. Okay, so let me write the cycle 8. So at cycle 8, right backstage. Perfect. Wonderful, right? For this execution, it requires R4 and R3, so there is no dependency here. Here it requires R2. There is no dependency, so no problem at the execution. So total in how many stages it's completed? Wonderful, good. Is that make sense? Is this activity helped? Yeah, total 8 cycles. So in your midterm exam, after doing this, you just need to write this. Yeah, Hele. You just need to write this total number of cycles. So here, you just need to write the total number of cycles. So in your reply, when you click on reply, just write total number of cycles. Total cycles is equals to 8. And just click on reply. Does that make sense? Is this a help? Yes, Jonas. Perfect. Noah, Austin, Jonas. Good. So we have one more example if you want. Okay. Perfect. So similarly, let's